Hi, everybody.
Live.
We went live.
Wow.
Are we live?
Yes.
Or is this Memorex? Ooh, who knows that commercial?
Not me.
I do. Is it live or is it Memorex? And they break
Go
the
ahead.
glass.
Knock this up.
And
I
they
showed it.
Duracell. Where's
Yeah, but
the
who did
beef?
it? Oh, yeah. It's beef. What's for dinner?
That little old lady.
Oops.
Now that you've had your history lesson.
Hey guys, we'll wait a few more minutes for more people to hop on.
Mike and I have chewed some dirt. Just saying.
We have.
We've been around.
And this getting old is not everything it's cranked up to be.
Oh, I don't mind getting old. It's the pain that goes with it.
That didn't hurt last week.
Yeah. Last week, fuck, it didn't hurt last
Yes.
hour. We're getting another BlueOn delivery.
Couple more minutes here and we'll start it up.
You guys can't hear me, but you can hear that delivery truck backing in. Hey, Jess, when's our next Buckle Up with Brian?
That's a great question. Our next buckle up is June 24th for summer service calls. That is the topic. All right, I think we can get started now. So welcome.
We are trying to get Jess wound down. She's like rubber band tight right now. This has been just a crazy week. We are breaking records here at BlueOn
Every day.
every day.
Okay, welcome back to Buckle Up. This today's episode is
Welcome
on
back to Buckle
is
Up.
on VFDs. Oh my gosh,
What?
someone said hi, Jess. Hello.
There you
Guys,
go.
I'm getting
See, you're
famous.
a star now.
This is a
with
big deal.
Mike and Brian.
Yes.
I don't know why you get top billing.
Because I'm older.
You're never here.
Because I'm older.
Nah, man, I love it when you're here.
All right, Brian, I'm going to pass it over to you to start talking
Okay, I
about
got it. Ready? Throw
VFDs.
it.
Ready, go.
Throw it. Boom. VFD.
Kind of a brown box that you plug in.
Well, could be gray.
Let's start at the very
Or-
basics.
Or black. If it's a Danfoss, it's got a red stripe.
And we're green.
And then there's green one. Hey, just in case you guys don't know, I'm not Mike, and he's not Brian. So we want to talk about VFDs today, I think. So VFD, what does VFD stand for, Michael?
Variable. Well, you say VS or VF?
I did. I said F.
Okay, variable frequency drive, but then everybody calls them variable speed drives.
Which would be VSDs.
Speed drives.
And then you could get into, but then you can also get into the old pen control, which was a big rheostat.
Or we can go back to the old drives where first you modulated the voltage, then you modulated the frequency. You had to do it in 2 steps. Or you could go into the 6-step drives. And you can hear it in the motor
As
too.
long as we don't go into a 12-step program, we're all right. Did I say that out loud? I'm sorry. All right. So variable frequency drives. What does the variable frequency drive do?
The variable frequency drive varies the voltage and the frequency, and the current goes along for the ride.
All right. So for the guys that don't understand what frequency meant,
Okay.
when you look at a motor, the motor has got voltage rating, and then it's got 3-phase, and then it's got a hertz rating.
50 or 60.
50/60, which means it's 50 cycles per second or 60 cycles per second. That's referred to as the hertz, or another term for that is frequency,
That's measured in hertz.
which is what the F stands for in VFD, variable
There we
frequency
go.
drive. So when the voltage changes so that they don't overheat the motor, they change the frequency as well. So at 460 volts, here in the old US, at 460 volts, it would be 60 hertz. but when you get down to 400 volts, it is going to be less than 60 hertz.
What would it be at 230? I'll make it easy for you.
That would be 30.
There we go. Easy math.
Half. That's right. Mike likes to make my math much easier. Have they started throwing in questions yet?
Not yet.
No, nobody's got a question yet. Hey, Mike, I got a question.
Huh.
What the heck is a true RMS meter? Can't I just use my Radio Shack one?
As long as it's true RMS.
As long as
Now, RMS means root mean squared, and
what?
root mean squared.
RMS, root mean
Mean
squared.
All right.
Is that a? No, I'm going to stop with.
You
the
better
jokes
stop.
right there.
Anyway, basically what happens with your AC voltage, I mean, if I said to you that twice a cycle there's 0 volts coming out of that receptacle, you'd probably say that's crazy, but actually there is. What happens is that 120 volts actually peaks out somewhere around about 180. And what's happening is the effective or average, more or less, is the root mean squared, the RMS, the effective part of the voltage.
So when you look at your meter, you have VAC,
Mm-hmm.
you have VDC. There is a symbol next to VDC, and it's got a line and it's got a dotted line underneath.
Because your voltage is constant.
DC,
DC.
direct current.
Yep.
Then you have VAC, and that usually has some kind of a little squiggly there,
Mhm.
right?
It's going up and down.
Up and down, because it's a frequency wave.
It's completing that 60 times a second.
Yes, it is. Up
There
and
we
down.
go. So what happened, some really, really smart people many, many years ago, instead of doing what we did in air conditioning for a million years, was driving the car by putting the gas pedal all the way to the floor and then controlling speed with the brake. Am I wrong?
Or Fred's feet.
Yeah.
I got that one.
So what they discovered, and really, really cool, is that by varying the voltage and the frequency, for the sake of discussion, we'll go proportionally, they were able to run the lower volts and lower frequency and develop less horsepower out of the motor and run it at slower speeds. This allowed them to save energy because as you drop down to about 90% of your connected load on a motor with a variable speed drive, you're going to pull somewhere in the vicinity of 50 to 60% of the incoming power. Now, if you drop down to 80% of your connected load, you're going to drop down somewhere in the vicinity of 40%. So you save a substantial amount of energy because you're now varying the voltage and frequency, so you get better control and energy savings with the variable speed drive.
And I would also, going back to my question on the true RMS, the reason that I asked that question, and I know you love me for this,
Of course.
is, let me get out my little, see, I brought paper.
Ah.
I brought paper just to mess with Jess, because now she's going to have to move her.
I was
You
just
planned
thinking about
this.
that.
She's gonna
I
have
was
to
just
move her
memorizing
camera.
where the
Or-
tripod was on
Or
the floor.
I can just come closer to the camera. So this is an AC wave.
Yes, we got more questions coming. Okay.
AC wave goes like yonder. And it does this 60 times a second. Top to bottom, 60 times a second. The reason for the true
So what is it from there to there?
start to finish. So what a variable frequency drive is doing is it's taking this AC wave and it is turning it into a DC simulated AC wave.
What does that mean?
And I'm going to draw it because I always found it was easier. Instead of being a curve, it is flat blocks. Doing the same thing. So you have your high and your low, but it's a DC current going out instead of an AC current. So this changes these blocks can be, if it was running at half speed or 460 volt motor running at 230 volts, there would be 30 of these per second. At 460 volts, there would be 60 of these. And that's kind of what the VFD is doing. It's varying this. It has to take the AC sine wave and turn it into a simulated AC sine wave. And the true RMS meter will show what your true voltage is versus just a standard meter that you would use to read AC voltage would not work here. You're not going to get the correct voltage unless it was at 100%. There you go. Thank you very much for listening. Mikey even agreed with me on that one. I wasn't a retard.
I didn't want to beat up on you on that one. I'll save that for later.
Yeah, okay. Fair enough. All right.
So you got questions?
We do.
I want to start
Brought
talking.
my own whiteboard.
We have one from
Okay.
Brad.
From Dad?
From Brad.
Oh,
From
Brad.
Brad.
Hello, Brad.
Hey, Brad.
And he's asking, I may say this wrong, but I'm going to do my best. I have an ABB VFD with the H01 code, but it's not an error code. I read the manual and customer support said no luck. I thought it was a Hertz, but it's not. The Hertz, but it's not.
Okay, I need to pull the manual back up to see what it is.
And that's just it. We'd be more than happy to help you guys if you call in on the tech support line over 20 ton. Click that and you'll get one of us that can look that stuff up. The ABB books are
300 and some pages.
and that's the small one.
That doesn't help programming.
Yeah, so it's not an H error code. That's fine, but we would have to dig into it. I mean, my ABB books. Well, I don't carry books anymore. It's all on a computer. But at any rate, we can look stuff up too.
Surprised ABB's tech support couldn't help them with that.
I know that's odd
'Cause
they
they
are usually on their game.
They're good.
They're usually on their game.
So guys, if you have any VFD questions, leave them in the chat, and Brian and Mike will answer them.
A lot of your common alarms for VFDs are overcurrent and undercurrent.
Ground fault.
Ground fault.
Yep.
The supply fans will ground fault a lot, and that's because they live in moisture, a high humidity area, being the supply fan. So you'll get ground faults on those a lot, which are kind of a false alarm. Some of the VFDs out there, you can have a warming to where it doesn't de-energize the motor all the at any time to keep the winding warm.
Yep.
And then the other tips and tricks part of this, I know Mikey knows this off the top of his head, and I periodically get confused. But VFDs with bypass, when you're doing a startup and you go into VFD mode and you start it up, the blower's going in the right direction, and then you shut it down and you test the bypass and the blower's going in the wrong direction. Mikey, which wires do we change?
If the bypass is wrong, you can change the incoming power to the panel.
So incoming power to the panel, if the bypass is wrong, everybody knows to switch three-phase power, you switch any two legs and it reverses the rotation. So bypass going backwards, you change the incoming power and don't change the output of the VFD. But if the VFD is going the wrong direction and the bypass is going in the right direction, you change the output of the VFD to correct that. Don't change the input because your output will be the same. Reversed.
The reason being because the variable speed drive is converting the DC to a simulated AC, and it's doing that and creating the phases accordingly. So
there's a fun
that was
fact for you.
That was always good for free lunches when guys would say, well, I'm just gonna change the input of the drive, and I say, okay. If it doesn't change rotation, you buy lunch, and they says, sure. Okay, they change it. I says, okay, that's good. You want to try for two?
Yeah, good stuff. Who else has got questions? Because I'm going to go into all this silly stuff.
Come on, guys.
All right, let's talk about a thing called pulse width modulation.
Oh,
Good stuff.
What is that?
that's all Mikey.
Okay. Pulse width modulation is when they came out with these really, really cool things called Darlington transistors or IGBTs. They were able to switch the transistors really, really fast. So what they would do is they would pulse the DC on to the motor, and they would pulse it really, really quickly. And then the next one would get longer, the next one would get longer, the next one would get longer, and then they'd start getting smaller. And so the average of each one of those pulses created what looked more like an AC sine wave. And then in days gone by, you walk by a VFD driven motor and you hear this ungodly loud whining. Whee! Yeah. So then they changed the carrier frequency and they were able to increase the pulse rate of the pulse width modulation. So they were able to get more pulses in there and get that switching frequency up above the audio range. So pulse width modulation, they've come out with some pretty cool things in the last few years.
And you can also, on certain drives, you can skip
frequencies. Now, the
skip
reason,
frequencies to stop noise.
Yeah, or, funny story, many years ago, Cal State Fullerton, 60-inch blower wheel, they
Yeah.
put a variable speed drive on there.
Yeah.
Now this blower wheel had been on there for 20-something years. So if somebody said, go pull that blower wheel, you'd be out there for a couple weeks. They put this variable speed drive on there, and the resonating frequency that it created, it loosened up the set screws and actually moved the blower wheel right into the housing, the most polished shaft you've ever seen. So what they came up with is they found that there are certain frequencies that, you know, maybe something vibrates in or just doesn't play
Loosen
nice.
bolts.
Yeah, loosen bolts or anything. So what they do is they give you a window. So the drive will come up to, let's say it was 25 hertz you wanted to get out of. Okay, so it would let the drive come up to 24 hertz, and then it wouldn't go any farther than that until it got a call to go to 26 hertz. So when it got the call for 26 hertz, it would skip over the 25
Yep.
and keep doing its thing. Because resonating frequencies are something that are, they can do a lot of damage.
Yeah, they can.
Get things shaking and the builds on each other.
And then these guys, I talked earlier about the rheostat type, and Liebert used that on their condenser fan motors, and it would choke the voltage to the motor, but it was still feeding at 60 hertz. So those motors, the amperage would go up, and they generate a little bit more heat.
They probably ran pretty high.
Oh yeah, they ran warm, but they were oversized motors. I mean, they put some engineering into it. And then a lot of companies are using VFDs as soft starters. And there is a difference between a soft starter and a VFD, but you can take a VFD, you can take a VFD and use it as a soft start, but you can't take a soft start and use that as a VFD.
Right, because a soft start, you cannot control the speed. You can control the acceleration rate,
Right.
you can't control the speed. With a variable speed drive, you can control where you want it to run at.
Yes. And it doesn't matter. The reason you can use it as a soft start is you can give it a start command and then tell it its ramp rate and just let it go to 100%. Or maybe you fix the 100% at 95% of the speed. Kind of like an ECM motor, only different.
Yeah. You know, since nobody's calling in, you know, we can kind of spread this out just a little bit. I don't know how many times I've gone out on cooling towers, and people are of the theory that if they run the fan faster and faster and faster, they're going to get more cooling. The problem is that you can only get so close to wet bulb.
Yeah.
So anything that you're running the drive beyond that speed is just wasted energy, and typically you're just throwing a lot of the water that you just put all that chemical in.
Out in the parking lot on those nice cars.
Exactly. Exactly.
We have a question.
Cool.
Okay.
How is a VFD different from a ECM?
ECM is messing with the commutation of the motor. Depending upon what tap you go in on, it'll give you a program speed based on what it was programmed for. A variable speed drive, we are actually varying the voltage and the frequency to control the speed of the motor. On an ECM, you're limited to what is programmed into it. With a variable speed drive, and you can actually overspeed a drive, you can take them up to, in a lot of cases, 400 cycles and make it run really, really fast. You just
Yes.
give up torque on it. So you can do a lot more with a variable speed drive than you can with an ECM motor.
And we use the term variable speed and variable frequency interchangeably,
Along with several other things that people have called them over the years.
like refrigerant and all its nicknames.
Oh yeah.
Good question. Any more VFD questions? Let's go. Anything you'd ever want to know about them, these two people can answer them for you.
All right, since nobody's asking anything, if you're looking on a variable speed drive and you're working with 460 volts, your DC bus is going to be about 660 to 680 volts.
Yes.
And the reason for that is because you're using the peak of the voltage.
And as you know me, I like to do all the safety PSA stuff. When you de-energize your main voltage, typically on all VFDs, there's some kind of an LED light that is blinking. Wait before you touch anything that all of those little blinking lights go out.
One of the
Otherwise, it will. That DC, that 660 volts DC will knock you on your keister.
back in the day,
In a
you know, since I've been doing that for 100 years, nowadays they put a bleed resistor into the capacitor.
Speed that process up.
Right.
But
Back in the day, because I did stuff with ABB for the better part of 30 years, and back in the early days, the capacitors didn't have bleed resistors.
yes,
So we would charge them up, put them in the box, and ship them back to
you guys are cruel. Yes, that's not
Milwaukee.
nice. That's
But then
not
they would
nice.
send the same kind of stuff back to us. So, be careful on that.
Yeah, I had a call on a VFD this morning, and it was actually the controller in the machine had the error code. So he looked up the error code, and it pointed us to the VFD. He goes over to the VFD, he looks at the VFD, and and it's a very common alarm, happens all the time, and it was off on overcurrent. So here's where you get into some tricky stuff on overcurrent. You can have overcurrent on the DC bus, you can have overcurrent of the motor itself, and then you can have under voltage and over voltage. But when the motor shuts, when the VFD goes to shut down, if your ramp rate is too fast, you can overcurrent the drive due to back EMF,
Counter EMF. Yep.
counter EMF.
Yep. You know, one of the things that they did many years ago, they had a bunch of drives tied in on stuff that had big flywheels on it.
Yeah.
And what they did is they went to a common DC bus. So if one of them was regenerating at the time, it would pump up the bus. So they didn't need to bring power in to bring it up. They were using some of that energy to regenerate. So there's a lot of things you can do with drives. Kind of the reason I got away from drives is that it got to the point that everybody was able to connect a few wires to a drive and make it spin.
Yeah.
And all of a sudden everybody was experts.
Well, they came up with this thing called an AC Tech drive. I don't know if that manufacturer is still there, but that was pretty much a cookie cutter,
Down and dirty.
down and dirty.
Yep.
Here's the chip. What are you using it for? Here's the chip. Plug the chip in. You ran start stop point and hooked up your incoming power and your outgoing power. Turn it on.
You know,
Pray.
the funny part of the variable speed drives, like take an ABB for example, you know, if they're using 5% of the functionality of the drive, I would be surprised.
Yeah, you get into drive if you're getting into drives, because you can use. I mean, Mike and I'm talking mostly about how it's affected in fans, but I mean, you can run fire pumps. You can run, and fire pumps run to destruct on exhaust fans, run to destruct. That is some crazy settings that when you get into them and you start working with people that are using the VFDs to their fullest, and you test, that made me sweat. We were on a very large building, probably a 26-story building, and we're up at the top running the VFD at 130%, and we're all in the fan room, and the fan room was as big as that simulator behind us, and they're running it no safeties at all. They were testing the bypass in fail mode, and yep, that was loud, lot of air, sweating, man. But that's just some of the dirt that Mike and I have chewed. So
Yep.
Someone said you gentlemen are legendary, and Mike is 100.
Mike's
He's
what?
150 years old.
No, I just feel like it.
we're goats.
You know, one of the functions that I loved on an ABB drive is if I had a 2-circuit condenser and I had all the fans tied in on one drive,
Yep.
I could take a pressure transducer off each circuit, tie them into the drive, and then set up the drive to control the highest
To the
of
highest
them.
one.
Yep. So I was able to use the drive to kind of do some down and dirty control without trying to put a bunch of other controls in to do it. There's a lot of functionality within the drives. I mean, back in the day it was all ABB, but now pretty much everybody's got a lot of this functionality in their
Yeah,
drives.
Yaskawa and Danfoss,
Yep.
and I mean everybody's got their finger into drives.
At one point in time, there were 243 companies making drives.
Is that right? Yeah. I remember. I mean, I did a lot of the larger package unit stuff, and it seemed like my route always had the carriers. And you get into these carrier box cars with the VFD in the blower section on the negative side of the evap coil, and there was always moisture issues on that.
Were those the Ultimars or the Snyders?
Oh no, that was ABBs.
Oh, really?
There was ABBs
Wow.
in there.
Someone said y'all should make a BlueOn unit.
Y'all, yeah, you're absolutely right. We should. I'm not going to, but we should.
We do have TDX20.
I'm not going to make it.
TDX20 is pretty awesome.
I don't even want to get into that.
All right,
I'm still waiting for you guys to hook me up with the Pepsi truck. I still got my stickers are all curling off of my beverage machine, and
go and tag Pepsi in a bunch of our posts and help us out. I've tried. Let's get brand sponsored.
yeah,
There we go.
my Bev Air machine, the stickers are peeling off of it.
Well, that's
It's
not
starting to
good.
look sad. But the Pepsi bottle is still there. It's curling in around it, but the Pepsi bottle is still on the side. Double slide door. Nice.
They knew how to
machine.
make stuff back then.
So,
I figured there'd be a lot more questions on VFDs.
I know,
did
me
too.
too.
I'm really surprised, guys.
Everybody must be out working.
Well, it probably got hot.
Yeah.
Somebody, something about, I don't know, summer may have hit. I know by our tech support line getting busier and busier every day that it's warm someplace.
Yeah.
I do keep an eye on the weather throughout the United States. Before we started, just to let you guys know, it's winter in Australia, and Newfoundland is 38 degrees today. It's a nice warm summer day in Newfoundland. That's Fahrenheit.
Oh, ow. Nope.
Remember the first time?
I had a gentleman call. This is totally off subject, but I thought it was the best question ever.
Okay.
Calls in on tech support. His question was, Brian, what is the temperature of this? What is the temperature of the liquid refrigerant coming out of this drum? I have burned my hands several times on this stuff.
It's called frostbite.
It was frostbite. So, here's the fun fact. R22, minus 41 degrees Fahrenheit and Celsius.
And?
And
Yep. That's the interesting fun fact. At minus 41, Celsius and Fahrenheit are exactly the same.
What?
And this is just up here floating around.
That's scary. I almost put an
Yeah.
adjective in there.
If you look at a chart, Fahrenheit and Celsius match at minus 41 degrees.
Wow.
That just always stuck with me. I don't know. Useless crap.
What's the difference between VFD and VRF?
Wow. Great question.
Great answer. VRF is using some form of a variable speed drive to control the refrigerant flow in the system, along with valves and things like that to go to the different units.
And just like VFD and VSD, there is VRF and VRV.
Okay, so give them the definition.
Same stuff.
Same stuff.
So one is variable refrigerant flow. The other one is variable refrigerant, I want to say volume.
I was going to say volume.
So a VFD is changing the speed of a motor or a pump. A VRF, VRV is changing the flow. It's changing the flow of the refrigerant through the pipe.
And then the compressor can slow down depending on what the needs of the system are.
And they're doing that with a VFD.
There you go.
Now, here's an interesting piece too, speaking of the VFDs on compressors. On these multi-stage, multi-head units, a lot of them will have, the first compressor will have the VFD on it, and then the rest of them are across the line. Another interesting fun fact for you.
You know, one of the biggest problems they ran into when they first put VFDs on compressors,
They broke.
nobody thought about having to drive that oil pump fast enough to maintain oil.
I got a tech support call coming in. BlueOn tech support, this is Brian. Hey man. Are you still there? Yeah, I can hear you.
Any more questions coming in?
Yeah.
I'm
What you
good,
got?
Zach.
Let me look. Do VFDs require reactors before or after the drive?
Typically, they were a line reactor,
What's it
which did some
what's it
filtering
doing?
on
You're
the
not getting
line
low
side.
voltage, high voltage? What are you getting?
There were several different, depending upon what you wanted to filter. When they went to the premium efficiency motors, there was a lot
Go
less
ahead,
copper
brother, I'm
and a lot
listening.
less steel in them, and so a lot of the electrical noise.
No, I happen to be in
could be
I
pushed
actually
back
am
into the
doing a
drive.
live broadcast.
So
and got
what
a
they would do
phone
is they
call.
would put
So
a
you're listening to my
filter
partner who's
on
still
there
covering the subject.
that
We're doing a
kind of gave
podcast.
an electronic filter of sorts. Typically, your reactors went in prior to the drive, filters went in after the drive.
What about between
You're now the
Y
main
and,
star.
and C?
Okay, let's see if we have any more.
Between Y and C at the board.
This may have been answered already, but what's the difference between an ECM motor and VFD drive?
ECM motors, we mess with the
No, I'm
commutation.
talking about the new
to
board
change
that you
speed.
put in the unit.
Variable speed drive, we change the voltage and frequency proportionally.
Okay, take the
You know, really kind of cool thing.
okay. Take
If you go to test
take the thermostat
a-
off the wall, leaving
the
subbase.
capacitors on the DC bus of a variable speed drive, a really cool way to do it is put your meter on AC, and the AC will show the fluctuation across the bus capacitors. So if you've got good caps, it should be just a few volts. If you've got really weak caps, you'll see that get up to 50 to 60 volts. So it's just an easy way to test bus caps under load.
Cool. Any more questions on VFDs? Let's drop them in the chat, and we will start to wrap it up.
Or if you guys want to spread it
No,
out to
you're-
anything else,
you're-
go for it.
Yeah, so take the thermos.
Heads up, our next Buckle Up is June 24th. So be sure to tune in, 4 p.m. Pacific time. We go live every other Thursday at that time for different topics. If you guys ever want a specific topic, just comment or DM us on Instagram, and we'll be sure to do it at some point. So.
Yeah, because these are for the techs out there. If there's topics that you want, ask.
Oh, you don't have a comment
because the goal is to help you out. So
jumper.
I don't care what the subject is. Neither does Brian.
And see if the outdoor unit comes on.
There's a real life tech support call going on right there. So we'll wrap it up here.
It's what we do, guys.
Yeah, sometimes Brian even puts on a suit.
They're not even going to bury me in a damn suit. Guys, get the app, update the app. We got the forum coming. It's that close to actually being here. I got this guy on hold, so Mikey, tell him all
right.
He hung up on me. That's not cool.
Make sure you update your app often. They are adding new things and new functionality and new equipment to it all the time. So the best thing is to set your updates for automatic updates. Like Brian said, the forum is coming soon. Really looking forward to that, because one of the things I've always hated about forums for air conditioning is everybody wanted to pick on the young guys. That's not what it's about. It's all about helping the young guys. You're our future, and young ladies. I don't want to be sexist there, but the young people that are coming into the trade, they're our future. And I enjoy nothing more than talking with them, helping them, answering questions. And I know Brian and all of our tech support team feel the same way. It's all about teaching you guys, and the forum is going to give a lot of information where you can ask your questions, and hopefully we're going to get a lot of the people from the community to jump in and help and just really make it something where everybody's helping everybody. So that's really exciting. The 3 options for tech support line are manuals. If you want just manuals, it's real easy. We have some research people that can turn around and find manuals for you. They're not going to be real good on tech support questions, but they'll be able to find the manuals for you real quick. And then it's under 20 tons and over 20 tons. The reason being is to get you to the right person quicker so that we get you taken care of. And again, just keep using the app. There's so many things coming on there, so many new things.
And if you guys ever have a unit that isn't already in the app, there's actually a link in our Instagram bio where you can submit what units you want in there that aren't already in there. So we really care about everything that you guys have to say. We want to make your lives easier, and if a unit that you work on is not in there, let us know and we'll be happy to put it in there for you. So remember that.
Help us help you.
Exactly. Brian?
And there's always stuff coming. New stuff is coming. I know guys are asking about, we still don't have all the furnaces in. We don't have all the air handlers in. We don't have all the coils in. We know.
Well, let's explain why that is. Okay, when BlueOn started out, BlueOn is a replacement for R22.
Yes.
So it was important to get all the manuals in there with all the steps and everything to make it as easy as possible for everybody.
To do retrofits on R22
Right.
equipment. So this has evolved into helping you guys, making your life better, making the world a better place to be one day at a time. So as long as it's not illegal or immoral, you guys need it in the app. We're putting it in the app. It is just grown from this retrofit little dinky app to 47,000 people.
Yeah, it's a whole support
on
platform
the
now.
app with we're approaching 200 tech support calls a day. We're bringing new people on every day, and everybody has the same focus. It's you guys are stuck on the job. You got a question. There are no stupid questions. I know you guys hear that all the time, but it doesn't matter how small of a question you think it is. If I get you through something 5 minutes faster, or take the monkey off of your back an hour sooner, if I get you home to the cold beer or cold pool or see your kids an hour earlier before the sun goes down, whatever that is, that's what we're doing.
But you know, one of the things is, and I've got some really good friends that are probably some of the top mechanics around. Bruce is one of them. And, you know, he would call and he would lay out the problem. And when he got to the end of laying out the problem, he goes, "That's okay, I figured it out."
Yeah.
And so the thing
It's because
is,
they call him Bruce.
but the thing is that a lot of times, as you lay out the problem to explain it to somebody as to what you're experiencing, you come across the answer yourself. And so I've told guys, you know, I may not know a lot about some of the things you're asking about, but I can always sit here and commiserate with you. You know, we'll talk it through, we'll work it through.
Yep.
You know,
You
and
got it,
sometimes that's all you need.
dudes. That's so cool of you guys. And someone asked, any support for chiller calls?
Yep.
As a matter of fact, we got some pretty good chiller guys.
Yep.
That's what a lot of what I did. We've got probably 3 or 4 really good chiller guys that can definitely help you out.
And to clarify, because we have to clarify, chillers come in a variety of tonnages and styles. So the next time you're at a drinking fountain, that is a chiller.
It is a chiller.
But not the one that you're talking about.
Interesting.
BlueOn Tech Support, this is Brian.
Speaking of, got your back with everything.
Yeah, man.
All right, guys. Zoom in Mike for his final
It's quite
farewell.
possible. You just put a board in.
It's important that you call us.
Okay.
We're here to help. I mean that sincerely. You know, the app's growing, the community is growing like crazy.
So did you take the
And
jumper from
it's
R
all you
to
techs
Y
out there,
at the sub base
techs, students,
and
you
did
know,
the condensing unit?
You're the
come on?
ones that are making the community grow, and this is for you guys.
Okay.
So, you know,
Now
tell your
go back
friends,
to the air handler
have everybody you know get on the app,
and do the same
and
thing.
you know.
Everything's free, so
But I
you
want
really,
you to-
really
what I want
cannot
you
go
to do
wrong
is I
at
want
all.
you to go from R
All right,
to
guys.
G
So again, June
at the air
24th, tune in for Summer Service Calls live, and that is it. So,
Thanks,
peace, y'all.
guys.